Okay. If y equals 2 to the x, then we get the usual table for the standard values. Now, if I want to do the base 2 log of y versus x, well, let's make a table. Okay, we want to do log base 2y versus x, and that's going to be our graph. Well, the log base 2 of 1/4 is negative 2. So, if x is negative 2, y is 1/4. Natural log of 1/4 is negative 2. Now, it's no coincidence that that's negative 2, since your table for the natural log of y would just be the invert of this table. But, okay, log base 2 of 1/2 is negative 1. And the values continue. So if you do log base 2 of each of these, this is what you're going to get. So you're going to have the point 2, negative 2, negative 1, negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2, and you're going to have a straight line that passes through all of those points. So, it's more or less obvious the graph of log y, log base 2y versus x for this function would be a straight line through the origin. We could do log of y versus x. Okay, so now our table would have again all the same values, and if we do log log of y, and you know, I actually, now the log log of 2 is about 0.3, okay? So I know that this is 0.3, and it'll follow that this is 0.6, this is 0, this is negative 0.3, this is negative 0.6. If I graph these points, then if this is negative 2 and this is 2, let's say you have negative 1 here, and should have extended this a little higher, but 1 is up here. then negative 2 is going to give you negative 0.6. That's going to be about here. And let me change my labeling of negative 2. So put it up here, it doesn't interfere with my point. So we get like negative 0.6 for the y2. So that's like negative 2, negative 0.6. And then we're going to get negative 1, and I'm not going to label this, but it's going to be negative 1, negative 0.3, and 0, 0 again, and 1.3, to 0.6. Should be pretty obvious that this is still a straight line. We could do this with natural logs. Okay, the natural log of 2 is about 0.7. So we would have like negative 1.4, negative 0.7, 0, 1.4, doggone it. My brain simply isn't any more connected to my hand than it was when I was 2 years old. Okay, so we get 0, 0.7, and 1.4. And if I was to graph natural log of y versus x, I have negative 1 here, then negative 1.4 would be about here, 0, 0 would be about here, 1.4 would be about here, and all my points would again lie on a straight line. Okay, let's just demonstrate that. If y is any logarithmic, any power of x, if it was b to the x, then you could make similar graphs, okay? B to the x is just a multiple of 2 to the x by the change of base formula that we looked at earlier. So if you have any exponential function, you're going to have a straight line graph if you graph any log of y versus x. Okay, so we can conclude, it's not a conclusion because we haven't proven it, but we can state with some reasonable indication that it might be true that if y equals b to the x, then log of y versus x is a straight line. And that straight line would be through the origin. What if y equals ab to the x? Well then, we'll say a little bit more. Log of y equals the log of a plus the log of b to the x. Because of course the log of a times b to the x is the log of a plus the log of b to the x. And this equals the log of a plus x times the log of b. Now if we graph x here and x log of b here. Now b is a fixed number, okay? B is a fixed number, so that the graph of y equals x log of b is a straight line through the origin with a slope equal to log of b. For the same reason that y equals mx is a line through the origin with a slope of m. If we replace m by log of b, that's got to be the slope of this line. Okay? It gets better. Then, if a is a fixed number, log of a plus x log of b well, log of a is some number. It might be a positive number, it might be a negative number, depending whether a is bigger than b, or whether a, in this case, is bigger than 10 or less than 10. Okay? Adding log of a to x log of b is just a vertical shift by a units. So if the origin shifts up to here, then this whole graph, to take this graph and get this graph, we've got to add log of a to all the y values, which shifts the graph up log of a units. And of course I missed, my line doesn't look all that parallel. But now this purple graph is log of a plus x times log of b. Okay, well that's a theoretical background to something, and it doesn't matter whether this is a log log or an ln log or a log base 2. It's all going to give you straight lines. They might have different slopes because, of course, log base 2 of b, whatever it is going to be different than log log of b, or than the natural log of b. But as long as you know what base you're using, you're going to be able to figure out what this equation's telling you. Okay, well, let's do a little algebra. I'll start a new video here.